In the Extension 1 course, we're going to have some harder inequalities to deal with. Now, the idea that they're harder inequalities is the idea that we have a denominator where we have an unknown. Now, we haven't had to deal with ones like that before. And this starts to bring in its own certain problems, because when we have, if it's an equation, then it's not a problem if we just multiply or divide by x and play around with it. But when it's an inequality, we've got to keep in mind that the idea with an inequality is that if we multiply or divide by a negative number, we change the sign. So if x only has one restriction here, and that's the case that x can't be equal to 0, then we have a problem. Then we have a problem is that if we try and multiply by x, is x positive or is x negative? So do we change the sign or don't we change the sign? We don't really want to have two inequalities in that regard. So to get around that, what we need to do is look at our denominator and square it. If we square it and multiply by that, then the denominator will be able to be cancelled and we start to get rid of the fractions that we want, like we have in normal situations with an inequality or an equation, then we want to get rid of the fractions. And that's what we need to do. Because if we multiply by the square of that number, well, it must be positive. Anything squared is a positive number. So that starts to leave us with a situation where we can go, well, x plus 4 over x, multiply by the x, leaves us with the cancellation, and we get an x outside of x plus 4, and that must be less than 3x squared. We expand it out and we can collect our like terms, and we get a quadratic inequality. We get a quadratic equation, and it ends up with a quadratic inequality. So in that case, what we've got to do is look and go, well, what are the values of x here that would make it greater than 0? So again, do a quick sketch of this quadratic, which will go through 0 and positive 2, and then see where the values are positive. Well, the values are positive here and here, which means when it's less than 0 or it's greater than 2. So keep that, look at that and do that, solve that inequality in that respect, because it was got to be greater than 2. Keep in mind that x can't be equal to 0. So if we look at the next one, first thing we should do, what are our restrictions on x? And it's not going to matter too much in this case. If it was equal to, then it would have a problem for us. But we've got to keep in mind, what's our restrictions? 1 over 2 minus x. X can't equal 2, otherwise it's going to be undefined. So again, 2 minus x, to help get rid of that fraction there, what we need to do is multiply by 2 minus x all squared. So we multiply by the 2 minus x all squared on both sides, so the sign doesn't have to be affected. We're not guessing about, well, is it going to be a change in sign or not. Start to clean it up, so do the cancellation, 2 minus x, expand that quadratic, keep expanding the brackets out so we can go and collect it all. So, and then we get a quadratic there that's going to factorize to this, and that's going to be less than 0. So again, do a quick diagram. Where is it cutting the x-axis? It cuts the x-axis at 2 and 5 on 3. So, or 1 and 2/3 if we want to write it that way. So what does that look like? Well, it looks like the situation where it's going to be between there if it's going to be less than. So there's our response. It's x got to be greater than 1 and 2/3 or less than 2 for this situation to occur. Again, 2 on x, less than or greater than or equal to x minus 1. Set out that x cannot be equal to 0. Multiply by x squared, because multiply by the denominator squared. And then start to collect our terms. Expand out, cancel, collect together. Then factorize, so the x outside of the x squared minus x minus 2, which factorizes to that. So this becomes a cubic. So where is this cubic less than or equal to 0? So if we draw up our cubic there, so we get it going through minus 1, 0 and 2. We know our shape of our cubic from our work on polynomials. So what we're saying here is that if it's going to be less than 0, for the function is going to be less than 0, we're looking at this part of the curve and this part of the curve here. So where it's less than or equal to 1. And now keep in mind that x can't equal 0. That's why we don't have an equal sign as well as the less than sign there. Sorry, greater than sign, because x has got to be greater than 0. It can't be equal to. So be really careful, because you get picked up on that, because x can't be equal to 0, and x is going to be less than or equal to 2. So finding that part there, but not including the x is equal to 0. Again, we get this one looking a little bit more complicated, but it's the same principle. X can't equal 4, we define that straight away. And then multiply by the 4 minus x all squared. It starts to get a little bit ugly, but you got to take a lot of care with the terms, because you got to expand, keep expanding all the brackets out, then collect them all together, and then we've got to use our extension 1 techniques. We don't have to do this very often, because a lot of times they work out as quadratics, but this one's a cubic. So again, find your factors of 48, and then find some terms that find some values with the factor theorem they're going to satisfy. And I've done it here for you: x minus 2, x minus 4, and x minus 6. So there's our roots there. So minus 2, 4, and 6. And what we end up having then is to look at where is that curve greater than. So between those and after there, again, because x can't equal 4, we've got to make sure we don't put an equal sign on that point there. Different type of inequality. This time, and the first part gets you to sketch, and this is one where we're just looking off the graph. So log of x, 1 minus x. If we graph that and then hence or otherwise, well, you can try doing it some other way, but wherever you see hence, look at the previous part. Where is log of x less than or equal to 1 minus x? And this is just a case of reading it off the graph. So when you look there, x is only defined for log of x between greater than 0. So we're going to have x is going to be greater than 0, but it's up to and including that point where it's equal to 1. So our region our range we're going to need there, or domain we're going to need there, is x is going to be greater than 0 or less than or equal to 1. And I've just read it off the graph. So I looked at where the curve in the red is less than the curve on the blue. And obviously it wouldn't be in that case because that's greater than. So it's only when it's less than 1 but greater than 0. And here's another one. The idea here, again, x can't equal 0, multiply by the x squared because that's the denominator squared. Collecting our factorizing, get the common factor, get that quadratic, and then where's that less than 0? We do a quick graph, and we see that, well, it's going to be less than 0 when it's less than 1, or between 0 and 2. And it wasn't too much of a problem here because it wasn't equal to, but keep that in mind that x can't equal 0. So if that was an equal to there, we'd have an equal sign there and an equal sign there, but not in that part. So that's how we do it. There's other ways to do it, and you can read text and have a look if there's other ways that you might want to do these ones. I think this is probably the easiest way to do this, but it all relies on you remembering that you cannot, if you're going to multiply by a negative number, you're going to change the sign of your inequality, and we're not multiplying by a negative because we're going to multiply by the denominator squared.